All right, so the second to last topic that we're going to talk about is finding area between curves. Okay? And actually, the idea is pretty simple. Okay? And I'm going to, like, off to the side, I'm going to kind of teach you the theory, which is this. Let's say I have two curves. Let's say f of x looks something like that. And let's say down here, I have something else. Let's say this is g of x. And let's say that I have a clear left boundary and a clear right boundary. Okay, so left boundary is A, right boundary is B, and let's say we're interested in finding this area. Okay, hopefully this will make some sense. If I did not have this green function, and I just wrote down the integral from a to b of f of x dx, what does that give me? If I didn't have the green and I just found this integral, what would this tell me?
Just the area underneath.
The area, the entire area, right, underneath f of x. Does that make sense?
Oh, I see. From A to B.
From a to b, right. And so now, if I only want the purple portion, does it make sense that I could just subtract g of x in here?
Yep.
Because the first portion gives me total area, and the second portion gives me the smaller area underneath the green graph. Okay? And so that's actually it. So anytime you want to find the area between curves, in the x direction anyway, if you have a clear left and a clear right boundary, you just subtract top curve minus bottom curve, do the integral, and then you're good to go. Okay? There are times when the top curve and the bottom curve actually trade places. Okay, and if that happens, we'll get there in a little bit. We have to kind of set up two different integrals, right? We can do like one integral at a time to find the areas. Okay, any questions on this idea, this concept? So area between curves is just top curve minus bottom curve dx. Left boundary to right boundary are your bounds of integration. Okay? And so we'll go through as many, well, probably the first three. Oh, did this print? It's printed funny. That's cool. Okay. So find the area between this graph, y equals 2 minus x squared, and y equals x. So 2 minus x squared, I know that's a parabola, a normal parabola that opens down, so I'm just going to sketch that. And the better you are at graphing, the easier this is. I'm a little off here. I just kind of whiffed, just completely missed going through that point, but you get the idea. And I got y equals x, looks something like this. Oh, I'm more than a little off. Hold on a minute. Let me resketch this. These points are a little too low. So ignore this, my bad. So vertex is here, point there, and then at -2, -2, and at 2, -2 are the other ones. So this is the parabola. And now y equals x, there we go, looks like this. And so we are trying to find, again, sorry about that, ignore, that's bugging me. I don't want to even want to see it. Okay. We're trying to find this area. We can use the same concept. Okay, so is it clear what our left and right boundaries are? What's the left x value? we're going from -2 to +1. Do you guys see that? Okay. And now this seems pretty clear. There's one curve that is always above the other one, right? What's the top or the upper curve? The equation for the upper curve is the parabola 2 minus x squared, so that's your f of x, minus the lower curve, that's the g of x. In that case, it's just x, y equals x. Okay? So this is it. That's your setup. And you guys have been doing definite integrals for a long time now, so this should be pretty much automatic. Once you get to this point, right, you just do the antiderivative. That'll be 2x minus 1/3 x cubed minus 1/2 x squared. And then we're evaluating from -2 to 1. Plug in +1. You're going to get 2 minus 1/3 minus 1/2 minus, plug in -2. 2 times -2 is -4. -2 cubed is -8 times -1/3 is +8/3. -2 squared is +4 times -1/2 is -2. And so this is the setup here, and you can either do that by hand or type it on the calculator depending on what it is, but I'll save the time here. If you do it right, you should get 9/2 or 4.5, which is pretty awesome. I mean, if you thought about finding this area when you guys were first learning about squares and circles and things like that, you would say, I have no idea how to find that area. That's a fun looking shape, but I don't know how to find the area. But now with integrals, we can find areas pretty much of anything, okay? Any questions on the first problem there? Okay. Now, and you guys can tell me, like, when we're done with the notes, if you want me to go back and actually do some of the integrating, I will be more than happy to. But I'm expecting that you guys know how to integrate. Like, if you can set it up, I expect everyone to be able to get this, okay? So my focus is going to be, when I go through these examples, is going to be just setting up the problems correctly, knowing that you guys should be able to integrate, and if not, I mean, you can probably figure out your mistakes, okay? So let's go through example 2 now. And let me try drawing the graph better this time so I don't have to redraw it. So here we have x squared plus 2. So still vertex here at 0, 2. Parabola opens up. So it looks something like this, roughly. And now we have y equals -x. So -x looks something like this. And they gave me x equals 0, so that's here. And x equals 1, so that's here. And so they want to find the area between all 4 of these. So that would be this, what almost looks like a trapezoid, except for this curved portion at the top. We're trying to find this area, okay? So again, we're just going to set up the integral. Is it clear what the left boundary is going to be? Someone at home, tell me, what is my left boundary and what is my right boundary? In other words, what is the lower integral bound and the upper integral bound?
1 and 0.
Which one goes where?
So 1's going to go on top,
Okay.
and 0 is going to...
Good, good. Okay, so that takes care of that and that side of the picture, right? What goes in here? It's just the higher curve minus the lower curve. Which one is the higher curve? Good. And then now we subtract the lower curve. That's just the line. I know it's a curve, but line, curve, interchangeable in calculus. Negative x. And so this is your setup right here. Obviously, you can simplify that, distribute the negative, and make it all positive if you'd like. But again, I'm assuming if you can get here, you should be able to do the antiderivative doing the reverse power rule, right? And just plug in the bounds of integration. And it's not a bad idea to go back and work through these. I'll give you the answer in case you do have a moment to practice this on your own, in addition to the Delta Math homework, but you should get 17/6 there. Any questions?
Is that 2.83?
Yes. 2 and 5/6, yeah. You can just do math frac.
This is easier.
All right. Questions? Everybody good? All right, example 3. Use a calculator to find this area. All right.
Did you do this on calculator?
Yes. But in this case, you'd have to do it twice, and here's the reason. Let's go ahead and graph these so we can see what's going on. So we got f of x is 3x cubed minus x squared minus 10x. And then we got negative x squared plus 2x. So these are the two graphs that we're looking at. We're looking to find the area between those two. And so we're looking for the area over here combined with the area here. Okay? Do you guys see how upper curve and lower curve flip-flop halfway through? Okay? So in this scenario, we have to set up two integrals. That's the only difference. Okay, so let's sketch what we got going on here. For the cubic, let's go ahead and find the intersection points. We want to figure out where these things meet to get a good, okay, so -2, -8. That's one of the intersections. 0, 0 is another one. And it looks like 2, 0, but let's make sure. Yeah, 2, 0. All right, so these 3 points that I have, that's the intersection for the two curves. And I have a cubic. And again, it doesn't have to be perfect sketch, but cubic goes up, comes down, comes back up. So here's roughly what my cubic looks like. This is just an aid, a visual aid. It's not so much needed for accuracy, but this will help me see what I need to do. And now my parabola is over here. Something like that. Okay? And so I've used my calculator. And again, what area am I trying to find? I'm trying to find this area right here and this area right here combined. These two areas between these two curves. Okay? So let me make the boundaries a little darker. Okay. So let's focus on the left portion. I'm going to call this area number 1. I'm going to call the right portion area 2. Okay? What would my first area be? What's the starting x value?
-2.
Very good. And we go all the way to 0 only. Okay, so we're just doing this portion. Because on this half, it's one curve that is above and one curve that is below, right? What is the higher or the curve that is always on top? That was the cubic, right? So 3x cubed minus x squared minus 10x. That's your f of x. Your lower curve was that parabola, so we're going to subtract negative x squared plus 2x. This is the setup right here. Okay? Area 2. That's this portion. We're going to pick up right where we stopped, which is at x equals 0, and we go to the last boundary right value, which is x equals 2. But the only thing that changes now is the upper curve is the parabola, so now we put that at the front, negative x squared plus 2x, and we subtract the cubic graph, which is 3x cubed minus x squared minus 10x. Okay? And it did say that we're able to use a calculator. Here's a good time to review some calculator skills. Let's go ahead and, since I've already got these typed in, okay, and maybe I think Mrs. Rand probably went over some of this stuff. Let's go ahead and find area number 1 on my calculator. So how do I get my integral up there? What do I press?
Math 9.
Nice. So then I just type in -2, 0. And now in here, instead of, I mean, I could type all this in. That's not a big deal. But I could just go to vars and then yvars function. And then now I could just hit enter and I don't have to type anything in. Because y1 is this. That's where I put it. Okay? And then I could just do minus, and then again vars, yvars, function, y2, saves me some button pressing. This is always going to be dx, and there's the first area. Pretty cool, right?
Instead of bars, you can go. Usually I do a Y and then go to. Oh, Y bar is the same thing as you go to alpha 4.
Alpha 4.
Then you go alpha, Y, and then you scroll to the 4.
Oh, cool. Something I didn't even know. All right, let's try the second one now. I like learning new tricks on the calculator. Okay, so for the second integral, math, integral, 0 to 2. And now we want to do y2 minus y1. The other place where you can find it, if you press alpha F4, you get it right away without having to like go through all those screens, which is kind of nice to know that shortcut. So I would just go y2 minus alpha F4 y. Oh man, that is so fast. 12 minus 12. Or I'm sorry, no, 12 plus 12. We're adding these areas, right? So this will be 12 plus 12. We get a total of 24. Well, my graph isn't perfect.
Well, on the calculator.
Sure it does. I buy that this area is about the same as that one. This one's taller and thinner. This one's a little shorter, but it looks a little wider.
A lot of it's more negative. I would think it's positive.
Well, remember, it's the total area between this curve and this curve. The areas by default are going to be positive. Does that make sense?
I thought they were asking for the actual area.
No, right. Yeah, so at this point, forget positive versus negative. Just think literal area between the two curves. Okay. Any questions? All right, let's go to next page. Again, let's at least... Why did this print all funny? I'm like missing... Oh. Well, they're here. Just very strange. Okay. Sorry. So this should be your page 2, right? For examples 4 and 5. All right, let's at least quickly set these up. Find the area between y equals 0. Here's y equals 0. Negative 2x. Slope is negative 2, so I'm just going to draw that in. And x equals 5. So what are we trying to find? This thing. Now look. I'm going to set it up because we need to know the calculus. Left bound is 0. The right boundary is obviously 5. What is the upper curve in this case? What's this equal to? That's 0 minus the lower boundary, the lower curve is, and it's kind of weird when it's like this, but think if I were to go bottom to top, right? You see how the bottom line, y equals negative 2x, that's the bottom of the area. The top of it would be the flat y equals 0, right? So that's why I'm doing 0 minus negative 2x dx. Well, that's not hard. This is just positive 2x. The antiderivative of 2x is just x squared. Evaluate that from 0 to 5. You get 25. So here's my next question. Did we have to do it that way to find the area? Yeah. This is just a triangle, right? So what else could you have done is this. Set up your integral and just say it's the area of the triangle. And just go, well, I know the area is 1/2. The base of the triangle is 5. The height is 10. Half of 50 certainly is 25. Okay? So you're totally allowed, like on the AP exam, if they're asking you to set up an integral or use integrals to find areas, as long as you have the setup, if you see a geometric shortcut, like, oh, that's just a triangle, I can do that area real fast, you can just say it's equal to the area of the triangle and do it that way. Okay? Example 5 I'm not going to do. It's pretty much the same thing. But I think that's good enough for areas with respect to x. I hope this makes some sense. I hope we're getting comfortable with integrals because, well, we're almost there. Okay? If you have any questions, let me stop this. If you have any questions,